All right, hello. Today we are going to look at a bivariate, which just means two variables graph called a scatterplot, which we've been working on in class, and it plots a quantitative explanatory variable versus a quantitative response variable. And really, the idea is it's just ordered pairs with each person having their value for the first variable, for the explanatory variable as its x coordinate for the dot, and the value for the response variable as the y coordinate for the dot. So it's just like algebra, just plotting a bunch of points. So the first one that I'm doing is using height and weight. So I've done some data management and a little bit of calculation to get height in inches for all the people in AdHealth, and then did some data management for the weight as well. And so the command to get the scatter plot is this one here. It's Seaborn again, sb.regplot. And so you put the explanatory variable as the x, the response variable as the y, and then the default, I'm going to take this out actually, so let me remove that. The default is that it plots all the points, and then it puts the variable name for the explanatory down here on the x-axis, and the variable name for the response on the y-axis. And that's fine, although it might be a little bit nicer to get a bit more description on here, which is why I put that X label. So it's the same kind of X label that is used in other graphs. It's PLT dot X label, and then you put whatever you want down there in your quotes. So when I run it that way, it just says height in inches, which is a little bit more descriptive and gives people a sense. Wait, these are awfully big numbers. Oh yeah, that's because 70 means someone's 70 inches tall. So that's someone 5'10", because 72 is exactly 6 feet. Okay, the other piece of this that I wanted to describe was this fit reg. Right now I have it equals false, and just looking at this, it seems like there's a bit of an association. It's not just a cloud of dots kind of randomly scattered. It feels as if, and this makes sense, that as much as there's variability based on body type and different factors, more or less, the taller you are on average, the heavier you are on average. Again, these dots are all over the place for people at 75 inches, but the lowest of the 75-inch folks is quite a bit higher than the lowest for the 57-inch folks, and goes up higher than the highest one. So in general, this kind of has this upward trend. And in a sense, what the linear model would do is try to figure out for each one of these heights what's kind of the average weight. You're trying to get a best fit line, the line where the total distance between the dots and the line is at a minimum, but that more or less just averages, in a sense, kind of averages the weight dots for each height, or it's pretty close to that. So if I make this true instead of false, and I've made the mistake a couple of times capitalizing true all the way through, but it's just the first letter that's capitalized, and Python's trying to, yeah, this is right, you said true correctly. All right, great. What that does is it just draws the best fit line. So this is the line that minimizes the total distance from each of the dots to that line. And it's more or less the trend that we can sort of see by just staring at this bunch of dots. Okay, I wanted to show you that before I did it with my own variables, because as I go through here and plot, and I'm going to just do false first for that best fit line. It would be really hard to say whether these dots are trending down or trending up, because they seem to be just kind of all over the place, no matter where you are. Almost feels like the variability gets less as I go out here. But other than that, there's not much I can say about different sibling numbers having anything at all to do with the age you're diagnosed with asthma. Um, and by making this true, it doesn't make it any better. It's like, oh, okay, so that's the best fit, not tour, but true. That's the best fit line. Okay. Not exactly sure what this cloud is for on the side of the best fit line. At some point, I should investigate that, but I don't want to do it to make this video. I want to be done with this video. All right. I hope that is pretty easy for y'all to do. I notice I put a title in there, and I wonder if I can. I'm just going to try it right here. Can I do a PLT title? To do kind of the same thing. And yeah, I like that better actually. So I am going to get rid of this. This was back when I was first figuring out how to do this, but I'm getting better at my Python. And so a PLT title at the top of this. And if you want to change the axis labels, you can, kind of like I did up here. All right. Have a great day. Talk to you later. Bye.